The exact value you have like can't simplify. As you know, sometimes there are square roots, you have simplify.
I simplified it myself. I put it into math and I still
So why don't you send me an email? Then I can check it.
just like, I mean, it's just multiple times really bad on the using homework because it just wasn't taking, like, when I had to put a list of roots, it just wasn't working, and I got like an email homework because it was just
Yeah, why do you say that? Because I will reply to it.
wasn't working. I'm literally just engaged on someone
For that one?
figure out how to
For the Lotus method?
I can write it like that.
for I just gave up on it. It's just, I tried all of them and I couldn't figure out
Yeah,
how
why do you
to
say
put
that I
it
can
in.
call you put a message to the whole class? Sometimes what happens is I see that in the one of the resource problem, they have to have exact number of decimal bases. Like 3 decimal bases, there will be 3 decimal bases. Why don't you try that one?
I mean, I don't think it said decimal, but I'll
Yeah,
check
3. Okay. So what we gonna do today? We gonna talk about one of the very important technique in integration theory. Okay, it's called the integration by parts. Integration by parts. So, and why this is important? And you can see that in integration theory there are two important methods, very important methods. One is the substitution method. And you can solve a lot of problems using substitution method. The other one is what we call the integration by parts. If you rank them, integration by part is the number one because you can do a lot of problems using this method. Okay? And so let's look at one of the problem and see what's going to happen if you try to use the method that you already know. Okay? So what we're going to do is the chapter 7, techniques of integration. Techniques of integration. Under this, we're going to talk about a lot of techniques. Like first one we're going to talk about the integration by parts, and 7.2 we're going to talk about the trigonometric methods, and 7.3 we're going to talk about trigonometric substitution, and 7.4 we're going to talk about partial fractions method. Okay, so a lot of different techniques. So this is 7.1. Okay, so what we call integration by parts. So it's like part by part integration, kind of like that. So before we go to the theory part, let's look at this integral. So let's say x squared e to the x cubed plus 1 dx. Can we do this one using some of the method that we already know? Yes. What's the method? Substitution. So what is the substitution? U equal x3 plus 1. But remember in the class we talk about shortcut methods. Okay, we really don't use substitution. We just write it as like we just check the format whether you have the derivative of the function. So the derivative is 3x squared. You already have x squared. So your answer is 1/3 e to the x cubed plus 1 plus 3. Is that right? Okay. This is what we did at the beginning of the class. Remember at the beginning of first week we were talking about shortcuts. So that way you can do it. Okay. Now I'm going to make this integral little simpler. But this is what we did 5.5 last semester. So I'm going to make this integral simpler. X ex dx. Now what? Can we use substitution now? not going to work. Okay, because you can see that if you start with ux equal x, what's the derivative? It's 1. This is not 1, this is x. So that means not going to work. So you cannot use a substitution method for this problem. Okay, this is even simpler than that, but you cannot do it. Okay, so that's the problem. So you cannot. Okay, that means we need new methods. Okay, the new method is what we call integration by parts. So before we go to integration by parts, let's try to like summarize what the kind of basic rules that we already have. Okay, so what are they? So let's like the basic formulas. Basic formulas. So I'm going to write, so there are 8 formulas. So let's write all of them. The first one, what we call the power rule. Power rule. What is that? It is x to the n plus 1 over n plus 1 plus c. This is going to work when n not equal to negative 1. If n equal to negative 1, we have this special case, 1 over x dx, that is ln absolute value x plus c. The second one, for the exponential function ex dx, it is ex plus c. If we have other bases like a to the x dx, so this is a not equal to e, so what's going to get? You're going to get a to the x over ln a plus c. You can see that when you put e as a as e, this is 1, so you're going to get the same formula. And the third one is the trig function, so it is sin x dx. So if it is sin x dx, what do you get? Negative cosine x plus c. And then cosine x dx equal to sin x plus c. And then number 4, the secant squared x dx equal to tan x plus c. Is that right? And then the cosecant squared x dx equal to negative cotan x plus c. Okay? And then what else we have? We have secant or tan. Okay, so we have secant x tan x dx. What is that? What is secant tan? Is secant. Okay, so secant x plus c. And then we have cosecant x cotangent x dx, that is negative cosecant x plus c. And then we have the sixth one. What about tan? Tan x dx. Tan you can write as sine over cosine. Now this simply becomes the log, is that right? So this is ln negative ln cosine. Because the negative sign, I can write this as secant x. Okay, plus c. And then there's a similar one for the cotangent x dx. This you can write as cosine over sine. This is ln sin x plus c. Okay. What else we have? We have more. So we have number 7, hyperbolic. Okay. So we have hyperbolic sine dx. What is that? It is cosine cos x plus c. And a hyperbolic cosine x dx is seen there's no negative sign in any of those. And then we have one of the tan inverses, we have 1 over x squared plus a squared dx. Anyone remember that? What is this? 1 over a tan inverse x over a plus c. And then we have 1 over a squared minus x squared dx. See the format. A squared comes first. This is sin inverse x over a plus c. And there's no 1 over a term here. There's 1 over a over there. Okay. And number 9, a plus bx square root dx. Because this is very common. That's why we did this. Anyone remember this one? There should be 1 over b first. And then 2/3 a plus bx 3/2. Okay. So those are the kind of basic results that you need to remember. Okay. So we assume that you know all of these. Just practice these ones. Those are the common ones. Now the thing is that there are like basic integrals. For example, the one we just had, like integral of x dx, you cannot do this using any of those methods. It's not going to help you. Even you can use substitution method. So you need a new technique. Okay. That new technique is what we call the integration by parts. Okay. So let's talk about the theory part of that. And you can see that actually in one of the other classes, it took only 15 minutes to cover the whole section. Okay. So that's easy. I mean, it's not that bad. Okay. But there are a few things that you need to memorize. Okay. So, okay. So integration by parts. Integration. I do it a kind of different way than the book. Okay, so you can see that it's not equal to what's in the book. So we have a shortcut, like easy way to do it. Integration by parts is the integral form of the product rule. Okay, integration by parts is the integral form of the product rule. So that means you start with the product rule. So let's look at the product of two functions. So let's say you have u and v, two functions. So do you remember the product rule? What's the product rule? uv prime, vu prime. Is that right? So this is equals to u dv over dx plus v du over dx. Is that right? Okay, that's right. Now you know that when u and v are functions of x, these are just functions of x, just a function. Okay, this can be a function of x. So that means these are functions. So that means you can just integrate this one. So you integrate both sides. Just integrate. Okay. So if you integrate, what do you get? Integral dx uv dx. Remember, when we talk about integrals, you always need to have the snake and that part, both. Okay. You need these two. Let's go hand in hand. For the next one, integral u dv dx dx plus the integral v du dx dx. Okay, and this is the formula actually. This is the formula, but we can write it in kind of different way. So what's really going on here? You first take the derivative and then integrate. So what's going to happen? They do cancel each other. Well, you have function, you take the derivative and integrate. Okay, so cancel each other, you get uv here. I mean, you can leave it like this, or we can make it simpler. So what we do, like we cancel dx and we can write it like this, u dv plus, we can write this as dx cancel, we can write v du. But there's nothing wrong like remembering like this, but we know we don't do that, we just go in like this. Okay, that's the formula. But how we write it? We can bring this term to the other side and write like having this one as the first term. So we can write u dv. If you bring this term to the other side, this becomes uv minus v du. So this is what we call the formula for the integration by parts. Okay. So that means you're going to start like this, and then you're going to go to this one. So both sides you have integrals. So in the theory part, what we normally do, you're going to pick u first. Okay, whatever the function. And you also going to pick dv first. So these two you're going to pick. The first one, you take the derivative, and then you're going to find du. The next one, you're going to integrate and find v. So this is what you're going to do. So you're going to pick u and dv, because see, you have u and dv. So you're going to pick u and dv. First one, you take the derivative. Next one, you're going to take the integral. Derivative, integral. Okay, so you kind of need all these four terms. U, dv, du, v. You can see that you have all of these terms. Okay, so that's the kind of theory part. That's how you start. You start with u and dv. First one you take the derivative. Next one, and the other one you take the integral. Now the problem is, what kind of choices you have for u? Okay, so there are a few choices for you, because it's not like you have to do this and you get the answer. So there are choices. Sometimes they work, sometimes they don't work. So but these choices like gonna work like about 99%. Okay, so these are choices for you. Let's say so I can write the choices for you. Okay. So one of the choices, if there's a x term in the expression, x and some other terms, so most of the time you're going to pick that x as u. Okay. And then if you have a long term like ln x, you're going to pick that as u. And then if we have ex and sin x, cosine x, terms like that, we normally pick this part as u. And if you have any complicated expressions like tan inverse or sine inverse, we're going to pick these as u. Okay, so those are the kind of choices for you. Okay, so that's it. So that's the theory part. Okay, so let's try to do problems. You can see that once you start the problem, this is very easy, very easy. So now, as the first example, let's try to do the one we got stuck. Okay, so what is that? Integrate. What was the problem? X, ex, dx. We know that we cannot do this one using any other previous methods. Okay, now let's see what's going to happen now. So what are our choices? So what are you going to pick as u? U equal? So what is the choice of u? Because how we pick u is, once you pick u, because you know that in the formula, you can take the derivative. So you're going to pick u so that once you take the derivative, it is simpler than the original one. That's the kind of trick we use. We use u so that once you take the derivative, it is simpler than the original one. So which is simpler than the original one? So which one you have to pick as u? X. You have to pick x as u. Because you can see that once you take the derivative, it is simpler than the original one. So it is x. So what is dv? dv means the rest of the function we're going to pick as dv. The rest of everything. So it is ex dx. Okay. What you can do the first one? First one you derivative. So if you take the derivative, what do you get? du over dx equal 1. If you cross multiply, you're going to get du equal dx. What to do for the next one? What to do for the next one? You're going to integrate. Okay. So if you integrate this one, so what do you get? So if you integrate both sides, what's going to happen? Ex dx. If you integrate dv, you get v. If you integrate ex, what do you get? Ex again. So that means you can see that we found all four terms. So that is always the first step of these kind of problems. You need to find these four terms. U equal x. You start with u equal x and you found du equal dx. You start with dv equal ex dx and you find v. Okay. So we need all those four terms. This one, this one, this one, this one we start with, and that one. Once we get all four terms, now you can use the formula. Okay? So let's use the formula. So what the formula says? This is u dv. Is that right? U dv. It equals to uv minus v du. That's the formula says. Is that right? So let's substitute. What is u? X. What is v? Ex. Minus. What is v? Ex. What is du? Ex. Now it is x, ex. What is this? What is the integral of ex? E to the x. This is where we're going to put the plus c. Plus c. That's it. Okay. So you can combine. So if you combine ex, you're going to get x minus 1 plus c. And you can see that once you take the derivative of this expression, you're going to get x to the ex. So it's going to work. So that means this is the right answer. Okay? So you can see that it's like kind of good method because this one you could not do maybe using any other method, but now you can do it. Okay? So let's do a few more examples. Is that right? So how we pick u? You pick u so that once you take the derivative, it's simpler than the original one. Okay? So it's simpler. Okay? It's gonna go down. Power go down. So let's do
Is dv just whatever's left after you substitute?
Yes, yes. Once you pick u, you're gonna put everything for the dv part, and then you're gonna integrate that one. So the first one you take the derivative. The next one you're gonna take the integral. Derivative, integral. Okay. Let's just remember this one as the rule. So it's easy. You start with u, take the derivative. You start with dv, take the integral. Okay. Good. So let's do a few more. So there are no new theories. Theory is over. It's just a problem. So how about this one? This is example number 2. X sin x dx. What is u? Very good. The rest of the part you're going to pick for dv. So dv equal sin x dx. First one you take the derivative, so you get du equal dx. Next one you take the integral, so you get v equal, what's the integral of sin x? What's the integral of sin x? Negative sin x. Negative cosine x. Very good. We have all four terms. Okay. Now you can see that this is u dv, so this is uv minus v du equal uv. So it is the product of these two. So I'm going to write the negative sign in front. So it's negative x cosine x minus v means negative cosine x du equal dx. Okay. So it's negative x cosine x, negative positive cosine x dx. This one we know. So it's negative x cosine x. What is the derivative? What's the integral of cosine x? What's the integral of cosine x? Sin x. Plus c. Don't forget the plus c. Okay? We normally do that at the last step. And you can try it. Just take the derivative, you can see that you get x sin x. So let's do more. Let's do examples. Third one. How about ln x? What is the choice for you? ln x, very good. And then the rest of the part, I'm going to pick as dv. So dv equal dx. Take the derivative. So du equal 1 over x dx. Integral v equal x. We have all the terms that we need. So let's put it there. So it is uv minus v du. So uv, that means you multiply these two, so it is x ln x minus v, that means x, du equal 1 over x dx. You can see there's something amazing happening. You can see that these two get cancelled. That's the goal, because once you put that du term, if you pick u as ln x, the derivative is 1 over x, that means this happened. That's what we needed. Cancel each other. Or make it simpler.
Can you move the paper over?
Okay. So you get x ln x minus dx. Derivative of dx is x, so it is x ln x minus x plus c. And if you want, you can combine the two. You can take x out, so you can get ln x minus 1 plus c. Okay. So those are a few choices. Now what I'm going to do, I'm going to teach you a different technique. So how about this integral? So what is your choice of u? What is your choice of u? U equal x squared. Okay. So the rest of the part is dv. So dv equal dx dx. So du equal 2x dx. V equal ex. So let's put it there. If you put it there, what do you get? It is uv minus v du. And we want to see this line every time. Okay? So it is x squared ex minus v means ex, du means 2x dx. So you can simplify, so x squared ex. If you take 2 out, you can get x ex dx. Now what happened? You start with this integral, you end up having another integral, but this is simpler than this one. Is that right? You start with x squared. What do you have now? X. So this is simpler than this one. So what you can do? You do this again. Okay. So I'm going to call this equation 1. So I'm going to do this one as a separate integral. Okay. That's what we do. So this is like our new technique. There are 2 steps. Okay. So let's do this problem as a new one. Actually, we already did this one, but let's do it. I want to show you how you normally do this kind of problems. So you do this again. So what is the new u? X, and then dv equal ex dx. So take the derivative. So du equal dx. then the integral, so you get ex. So it is uv minus v du. Substitute, so it is x ex minus v means ex, du means dx. We can do this, so it is x ex minus ex plus, I will call this c prime. For some reason it will be clear later, just in few minutes, why I pick c prime. Okay, so that means we solve this one. Now what I'm going to do? I'm going to substitute this one for that, because this integral equals to this one. So I can substitute. So I can say using 1 and 2. Okay, so using 1 and 2, I can write like this. My original integral x squared ex dx equals to this part minus 2 times, I'm going to substitute for this one, 2 times, I'm going to substitute that, so it's x ex minus ex, I substitute this part, okay, plus c prime, so if you simplify you get x squared ex minus 2x ex plus 2 times ex minus 2c prime, okay, so that's the answer. That's the answer. You can see that there are no more integrals. We normally, like if it is an exponential one, you can take ex out most of the time. So it's x squared minus 2x plus 2. And this whole thing I'm going to call c, just to make things easy. That's the answer. Okay. And you can see that here what you have is, just take a repeated derivative, x squared. If you take the derivative, it is 2x, you change the sign. You take the derivative again, it is 2, change the sign. So you change the sign and take the repeated derivatives. But don't use that as a formula. You don't get points if you do that.
So no matter what's in front of c prime, you just make it c at the end.
Yeah. Because this is just a constant.
Okay.
I can call this constant c. Okay, just to make things easy. So whatever you have at the end, just make, you collect everything and put just c for that.
Sorry, what's equal to what?
This part, I call it just c.
You were able to sub, I think, where you have a 2 with the circle back in.
You mean this one?
Go up. Up.
Equation 2. Saying where you took the integral, you use the formula 6 and up.
Yeah, you mean this, here using 1 and 2.
Okay. It's x edx minus edx, right?
Yeah.
And then that's supposed to be equal to x edx. Yep.
You mean this one?
Yeah.
Which one are you talking about?
Yeah, that one.
Yeah, so what I did this integral as a separate problem
Yeah.
and get this one.
Yeah.
Once you get this answer, you're going to get substitute this one back here. Because this whole integral equal to that.
Oh,
So what I did, my new integral, this one, we know that this equals to that,
yeah.
but this part equal to that, so I substitute this one here. So that's why, so I start this one, this equals to this part minus 2 times, instead of this one, I write that. Okay? And then I simplify. Just multiply by negative 2 and simplify, and you get this. Okay, so this is like kind of a new one. I can put a star here. It's like 2-step method. So that means if I give you the problem with x3, what you will do now? 3 steps. Because in the first step, it's gonna go to x squared. The next step is gonna go to x. The last one is gonna go to bring down to ex. Okay. So these are the number of steps you need. Yeah, the maximum, like you can go for 2, but for your knowledge, I mean, you should be able to do anything. Okay, but we don't ask that for the exam. We cannot. So let's do more. How about this one? Number 5. Let's do a problem with numbers. Okay. Let's do a problem with numbers. Like let's say 0 to 1. Tan inverse x dx. There's nothing new. You just substitute the numbers. Once you integrate, you substitute the numbers. Okay, that's it. Okay. So, what are the choices? What are you going to pick as u? Tan inverse x. What is dv? dx. So u equal tan inverse x, dv equal to dx. Take the derivative. So du equal 1 over. Very good. What is v? X. Okay, so we have all four. So let's substitute. So it is uv minus vdu. So what is uv? X tan inverse x. Okay, now you can put the numbers. Let's write everything first. So it is what is v? X times x squared plus 1 dx. Is that right? You multiply these two. So let's put numbers now. What are the numbers? 0, 1. So this is where we're going to put numbers. 0, 1, 0, 1. Right after you get these expressions, you can put these numbers there. So, if you put 1, what do you get? If you put 1, this is 1 tan inverse 1. If you put 0, it is 0 is gone. Minus this integral. So how do this integral? How to do this integral? Very good. Because you can see that what's the derivative of this one? 2x. We have x there. So 2 is missing. So you put 1/2 and 2. You can write this as tan inverse 1 is pi over 4 minus 1/2 ln x squared plus 1 1 0. We don't write this as substitution anymore. That's what we did in when we were kids. Is that right? So we don't do it now. You do that step like from your head. Okay, let's put 1. If you put 1, what do you get? If you put 1, you get 2 there, ln 2. If you put 0, this becomes ln 1, that is 0, so it's gone. Your final answer is pi over 4 minus 1/2 ln 2. Is that right? Or you can write this because you can just bring this one there, and you can write this as pi over 4 minus ln square root 2. Good. So that's it. Okay. So we cover like almost all. So let's just do a few more. We have time. So let's do a few more. So let's do some complicated ones. So complicated integrals. Okay. So the sixth one. How about this one? Ex, let's say sin x dx. So which one you're gonna pick as u? E to the x. Okay, so if we have sine, cosine, exponential function, we normally pick ex. Okay, again, there are no general rules. How are you gonna pick it? We wanna pick u so that we can do the problem. I mean, that's it. Okay. So what is the most of the time ex gonna help you? But for this problem, even you can pick sin x. It still work. For this particular problem, it doesn't matter. You can pick any of these as either this or that. No problem.
But you usually pick e to the x.
We normally pick e to the x. Yeah. So let's do that. So u equal ex. The rest of the part we're gonna go for dv. So dv equal sin x dx. Take the derivative. Take the integral. Is that right? Okay. So, what we have? uv minus v du. So uv means minus ex cosine x. The product of these two. Minus v du. Okay. So minus, this is v, du. Is that right? If you rewrite it, what do you get? You have negative ex cosine x plus ex cosine x dx. So what happened? So what really happened? You start with ex sine x. What happened now? It gives you ex cos x. So what you guess? Just do this again. So I will call this equation 1 and just try to do this again as a separate problem. So ex cosine x dx. So what is your new u? What is your new u? It is still e to the x. What is dv? Cosine x. Take the derivative. Take the integral. Okay. So let's substitute. If you substitute, you're going to get ex sine x minus v du. That means the product of these two. Product of these two, so I can write ex first. So it is ex sine x dx. Is that right? Now what I can do? I can substitute this one for that. Is that right? So let's do that. So using, I'm going to call this one equation 2. So using 1 and 2, so using 1 and 2, I can write my original integral ex sine x dx equal to this part minus ex cosine x plus, but for this one, I'm going to write down because they are equal. So I can write ex sine x minus ex sine x dx. So now what happened? Do you see something strange now? You can have integrals on both sides, but they are equal. So what you can do? You can bring this one to the other side. Whenever you have something other than this, you can do this. So this has to be something other than that. Because if these two are equal, what will happen? They cancel each other. So you can't do anything. But if you get something other than that, it doesn't matter whether you have a negative sign, positive sign, but this has to be something other than that. Because then you can always bring it to the other side. Is that right? So we can do that. So we bring it to the other side. So if you bring it to the other side, it is 2 times ex sine x dx equal, if you want, you can combine these two. You want to combine? Just combine. Ex sine x first with as positive and cosine x. Plus c prime, I put c prime there. Now what you can do? Divide both sides by 2. This is a very important trick, like if you are in engineering or physics or chemistry or biology. This is like a very common problem that you're going to see. Engineering and physics, you're going to see this in like sophomore or junior level. But for biology, when you go to higher studies, masters or PhD, or you need to do this. Okay. So this is a kind of very common trick. So you're going to c prime by 2. I'm going to call that c. That's the answer. Okay, so it is like two-step process. Okay, it's going to go through two steps. You start with this one, and you're going to get EX cosine. Now you do this again, and then you're going to get EX cosine X again with a negative sign. So you bring everything to one side, divided by whatever number you get. Okay, so this is a very common trick. Very common trick. Okay. How much time do you have? 5 minutes? Okay, we can do one problem. Okay, so let's do, so that's it, this is just a trick, okay? Let's just do one more. Okay. So how about this one? 1 to 2, x 3 half, ln x dx. Okay, I let you do this. What do you try? So which one you're gonna pick as u? How you pick u? Once you take the derivative, it's simpler. So which one you're gonna pick as u? ln x. dv equal the rest of the thing. So it's x to the 3 half. First one you take the derivative. Next one you take the integral. So what's the integral of this? This is a power function. So it is 2/5 x to the 5 half. Okay. So let's try it. So it is uv. So it is x 5 half ln x straw 2 1. Okay. Minus v du. What is v? 2/5 x to the 5 half. What is du? 1 over x dx. 1 to. Okay, now let's put 2. So if you put 2, what do you get? If you put 2, you get 2/5 2 to the 5 half ln 2. Is that right? If you plug in 1, what do you get? It's 0 because of ln 1. So it's gone. Minus, well, let's simplify this one. I can take 2/5 out. You get 1 to 2 x to the 3 half dx. See? That's why we pick u equal ln x, because then they're going to cancel each other. Now this is the easy integral. So you're going to get 2/5 2 to the 5 half ln 2 minus this 2/5 another 2/5 x to the 5 half 2 1. So let's combine this one. This is a 2. If we add, it's become 2 to the 7 half. Is that right? Or 5 ln 2 minus, so 4 to the 4/25. If you put 2 to the 5 half minus 1. Okay. I save you 1 minute. So you can see that this trick is very easy method, but only thing is you need to remember how you pick u. Okay. So how you pick u? You pick u so that once you take the derivative, it is simpler than the original one. Simpler than the original. But there are a few choices: x, ln x, dx, tan inverse x. Hello?
Is there ever going to be a time where if you pick them all once, you can't do the problem? Or are they just hard?
No, you can do like, for example, just switch the other like all these problems. Just pick u equal x. You can. No, we don't know what's the derivative, what's the integral of ln x. We don't know. So you can start. Right there, you can start. So you make it more complicated. Because once you take the integral of this one, it becomes 5.